Hello there, this is our demonstration for Visual-1 3D Visualizer. So this is one of the features that we intend to include in the Visual-1 suite, and this is basically just a 3D graphics sandbox that allows you to draw some solids and to apply transformations to them, okay? And we're going to be able to see what exactly a transformation is and what is the linear algebra being applied here. So to start off, let's look at the 3D graphics panel. Now to move about this panel, I can just left click to drag and I can pan around the camera up, down, left, and right as you would expect. I can also right click and drag to roll. And I can also press W, A, S, and D to move just like you would in a video game. Pressing space goes up and pressing shift goes down. Finally, if I middle click, it will return to the default position. Now there's a lot of nifty little buttons here that just say the transformations that you can apply to an object, but if I were to click any of them, you will see that I can't do it because I haven't selected an object yet. So that's what we're going to do. When you start Visual-1 3D Visualizer, a cube will be rendered in by default. So if I click here, it will actually highlight the cube that's already on the screen, and it will draw a border around it. I can show or hide the object from view, and if I hide it, it will still show the wireframe, but the shading will be gone. So that's pretty useful if you want to declutter your screen if you have a lot of objects. Now we're going to try translating. The red line is the x-axis. So this is the positive x-axis, this is the positive y-axis, and this is the positive z-axis. So if I were to apply the transformation, translating by 1, 2, 3, it will, translate upwards like that. Okay? So it does a vertex-wise transformation on each of the 8 vertices of the cube. You'll also notice there's an additional line here in the middle. That's because this is actually the center of the cube. The reason we have to find the center is so that we can scale objects up at their center. So to demonstrate that, I'm just going to click this, and I'm going to enter a scaling value. If I scale it up by 2, it will scale about the geometric center of the solid. If you realize, hey, that's not what I wanted to do, I can press undo. Okay? If I click undo, it goes back to this, and if I click undo again, it goes back to the original position. So that's cool. Now, what else can we do with this? We can reflect about a line, but before that, let me translate to this position first. Okay. Let's say I wanted to reflect about a line. I can either select an existing line to reflect about or specify a one-time use line. Now we don't have a existing line yet. You can see over here that the line plane panel, it's empty. So instead we're going to have to specify a one-time use line. When I click this, you'll see that I can enter the vector equation of a line. So this is very familiar to most of us, I hope. This little 3 boxes on the left is just the coordinates of the fixed point, and these 3 on the right is the direction vector for the line. So if I were to enter, for example, -1, +1, +1, then the fixed point would be somewhere about here. And if I were to enter 1, 2, 3 on here, then this should reflect about that line, and you can see that that line has been drawn in yellow, and every vertex, once again, has been applied vertex-wise to reflect about this line. But this is only a temporary line. It will disappear if I make another transformation. So for example, 1, 2, 3, that line has disappeared because it is no longer in use. However, if I undo, that line will appear again. Now, we can also add a permanent line. Now the same kind of window pops up, and again you can specify a line. Now if you leave a blank in the box, it will actually be 0. However, of course, a 0 direction vector is no good for a line. If I were to try and submit this, it will tell me that a 0 direction vector or normal vector is not allowed. And of course, if you try to be strange and put something that you can't, that's not going to happen. Okay? So make sure everything's a number, and make sure your direction vector is not 0. So let's just put 1, 2, 3. And now we're going to put this, when it's empty, it will be taken as a 0. So this is going to pass through the origin. So now I have a line here. This is a permanent line that I've just added, and it's parallel to that yellow line, but it passes through the origin. If I were to click reflect line again, I can now reflect about that line I just made, and it will actually highlight that line for me. If I were to instead specify a one-time use line, that line gets de-highlighted. Okay? If I click submit, it will reflect about that line, and now this line becomes yellow because that's the line that I just applied a reflection to. Okay? What else can we do with this? we can also add a plane in the same manner. So now we can enter the Cartesian equation for our plane, which is, for example, 1, 2, 3, and 4. Okay, so now that plane appears over here. You'll notice that there's a checkbox on each line and plane. If I click the checkbox, it makes that thing hide. So that can be quite useful. Now, because this yellow line is still here, that's still going to show regardless of whether I'm hiding this or not. Okay, so let's try reflecting this cube about the plane that I just made. So I can either specify the one-time use plane the same way I did with the line, or I can just use the one that already exists. It will highlight accordingly. Okay, as you can see, I have reflected about the plane, and it has drawn in that reflecting plane in blue. Okay, so that's how that works. So yes, you can apply some transformations, and let me just show you one more nifty feature, which is this little matrix stack. Okay, if I click this, it will show me all the matrices that have been applied to the currently selected shape. So it starts with the identity matrix, followed by a translation. Okay, so the reason why this is a 4x4 matrix. Okay, so a linear transformation from R3 to R3 must preserve the origin. However, our transformations do not preserve the origin, especially if your line or plane doesn't pass through the origin. That's what we call an affine transformation. And if you wanted to represent it as a linear transformation, you have to make it R4. And that fourth coordinate is so-called a homogeneous coordinate. And in essence, this row at the bottom is always going to be 0, 0, 0, 1, so that when you do the matrix multiplication vector-wise, each vector is just the position followed by a 1 at the bottom, so that when I do the multiplication, you're just going to get you're just going to take this vector as the translation vector after applying this little transformation on the first 3 columns. So that's the function of the fourth coordinate. So I can translate, reflect about a line, and reflect about a plane. So you can see each of these little matrices just tells us exactly what matrix was applied to get to that point. Okay, now we can actually add more shapes than just a cube. So let's reset ourselves to the default position, and I'm going to add myself a tetrahedron. It's another default shape, and when I click this, it will tell me I can specify the size and offset. So the cube and tetrahedron are unit cube and unit tetrahedron by default, and they are generated at the origin. So I can scale this up, and I can offset it by -1, for example. And where should I expect to have it? Over here somewhere, right? So let's do that, and you can see that I've just generated a new tetrahedron. And the unit length of the tetrahedron, it's 2 units. And yeah, it's a regular tetrahedron that's centered at -1, 0, 0. I can also apply transformations using the very same objects that already exist on the screen. So let's project it onto that plane, for example. So you can see here that I've projected my tetrahedron onto a plane, so now it is a flat shape rather than a 3D shape. Okay? Now we can undo that, of course, and I can also rotate about a line, for example. So I can choose a line that already exists, and I can enter the rotation angle. I'm going to put 45, and it rotates about that line. It may be a bit hard to see that I actually did rotate about the line, which is why I have this nifty repeat feature. So it allows me to repeat a certain number of transformations from the past, and I'm going to repeat the last transformation so you can see that repetition. And because the last 2 transformations were both rotations, I can repeat this 2 times, and now you can see here, you can more visually see that this is a rotation about the line. I can press undo a bunch of times, and you can see that the tetrahedron did indeed rotate about that line. Alright, that's cool and all, but now there is a caveat here. If you reset the current object or delete the current object, which may be something you want to do, if you just want to put things back to normal, you need to be very wary of something, which is that it completely destroys the undo stack, and you will not be able to undo any transformation. So both of these were not at the original position anymore from when they started. If I were to reset the position of this tetrahedron, then you will see here that this, actually it was at the correct position. It was at the original position over here. Let me try that again. So if I were to translate this up here and then click reset, it goes back to the original position. But if I select the cube, I can no longer undo the movement on the cube. It's stuck there where it was because the stack has been destroyed. if I were to translate this cube and then delete this tetrahedron, then this cube, I can't undo it either, it's stuck there. So that's something to be wary about when you reset or delete objects. Now we can hide and show lines and planes as well, just by checking the box once again, because the screen might get too cluttered if you have too many lines and planes. You can also delete lines and planes. You can delete the line that I have here. I can delete the plane that I have here if I don't need it anymore. Okay? Now let's delete this cube and let's put a new one in place. Okay? So when I put a new cube in place, it's going to be named cube 2 because I had a cube 1 just now, so it prevents name clashes automatically. Okay? So that's just a nifty little example. Now, what I think is the coolest thing you can do with this graphics sandbox, however, is create a new object. So let's add a new 3D shape. You may have noticed the Add New Solid button over here. So if I click this, and it will ask me to select a polygon or create a new one. We haven't created any polygons yet. Let's add a new polygon, and we're going to upload a CSV of vertices. So you can see over here that I have a few good examples already. So invalid 1. This is just going to be a set of points that doesn't actually work. So what is that? Oh yeah, you can't see that. Hold up. So this here obviously is just going to be 3 points at the same place, so that doesn't really work. You can't really fit that. Let me just shrink this down a little bit for you. I am actually using a dual monitor to record this. Okay, so obviously this is not going to work. If I put it in, it's going to tell me that the points can't be well fitted to a plane because of some eigenvalue calculation. So internally, when you pass in a CSV of a 3-coordinate system, it uses the singular value decomposition formulation of calculating the total least squares best fit plane, but the singular value decomposition also reveals the eigenvalues, right? And if we notice that something's wrong with the eigenvalues, then it doesn't really fit on a plane, the program will tell you. So that's good. So another invalid example would be this one. This here represents a cube, right? So if I were to pass this in, it also tells me that I cannot fit this to a plane, albeit for a slightly different reason, again regarding the eigenvalues. Now let's try some valid examples. Let's try the non-convex hexagon. Okay, so this is a 2D plane. So you can see here that I have specified a CSV, but there's only 2 coordinates, x and y. When I specify it this way, it will just generate on the xy plane automatically. So if I were to pass this in, it will say that I've successfully parsed in my 2D points. So now let's name this polygon. Let's name it hexagon. Let's click submit, and you'll see that it's actually kind of automatically generated that plane there for you. So that will disappear if I click this button over here, add new polygon, but if I wanted to add that hexagon, I could. I can also delete this hexagon if I don't need it anymore, but otherwise it's going to stay there. I can add another polygon if I so wish, but for now, we just want the hexagon. Now we can make a prism or pyramid using the base polygon. We can then name the solid after the fact, but let's choose a pyramid or prism first. If I choose a pyramid, it will ask me to enter the coordinates of the apex, and if I choose a prism, it will ask me to enter its height. Okay, so let's make a prism. Now, names of polygons and solids can only be alphanumeric, and they cannot be blank. So special characters and spaces are a no-go. In fact, if I just put an exclamation mark here, that's not going to work. Okay, and because there's already a cube and a tetrahedron, obviously you can't name this a cube either. It will tell you that's not going to work. So let's name this a hexagonal prism. Again, there cannot be any spaces. Click submit, and there you have your hexagonal prism that I've just drawn in, and I just made that custom shape by myself. Okay, and all the same transformations work on it, right? I can scale it down if I think it's too big. I can translate it. I can rotate it about some line. I can specify a new line. Let's just specify, I don't know, such a line. I can literally just reflect it about that line I just made. Everything is the same as it was before. Okay, so that's pretty nifty. So now I'm going to show you the other example. So we're going to add a new solid again. Again, I can actually just reuse the hexagon to make a new solid, but we're going to add a new polygon instead. We're going to try the next example, which is a regular pentagon. This, again, is a 2x2 CSV. So you can't really see it, but this is representing the regular unit pentagon. So we've added that in. We're just going to call this a pentagon, and we're going to submit that. And we can now create, let's try making a pyramid instead. Okay, so that is going to be a pentagonal pyramid. And we're going to enter the coordinates of the apex. Let's set the apex to be 0, 0, and 2. Okay, so now I've drawn in my pentagonal pyramid. And yeah, that's pretty cool. I can also translate this away. Let's translate it away. Okay. And again, you can hide it, you can undo, you can do everything you could do with everything else. Okay, this cube, I don't really need it anymore, so I'm going to hide it. Okay, so you can see here that it's still showing me the other ones, and the cube is still there, I've just hidden it. Okay, now we're going to try one more. Let's add a new solid, and we're going to add a new polygon again. Now this one is a slanted crown, so this is a three-dimensional CSV. So this one is special because it calculates the equation of the plane of best fit, and then it actually displays it for you. So we're going to call this one a crown, and again it renders in for you, but if I were to click a different one, then it will just render that other one. Okay, let's click a crown, and I can actually delete this pentagon if I don't need it anymore, and it will be removed, for example. Now let's submit the crown, and I'm going to call this a pyramid. I'm just going to put this at the origin. And I'm going to call this a, I don't know, let's call it a crown pyramid, why not? And it will, again, generate exactly as you expect. It's kind of a small, it's hard to see that it actually is a pyramid, but yeah. So that works. Okay. So I've generated all these cool little shapes now. Each of these shapes has their very own matrix stack, and you can just read them off, just like you would with the regular shapes. And you can still create lines and planes. Let's create one more plane, actually. Let's call this one 2, 3, okay, 6, and 7. So here's another plane. I can, again, do the same thing I've always done with everything else. I can reflect in the plane. Let's reflect the hexagonal prism, this one right here, about that plane. And that still works, right? I can hide that plane. I can hide that line here. All of it works, but yeah, everything's the same. I can put it back. Now, all of this is pretty cool and all. I think I've shown just about everything that we can do with Visual -1 3D Visualizer, but there is one more thing. You can actually save and load your progress. So all of these objects are internally represented as JSON files, yes. So you can save the entire thing as a JSON file. So if I were to click save, I can actually name it something. So let's come back to this folder. We're going to call it test.json. Okay, so this gets saved, and now I could do anything. I could just delete everything. Okay, let's delete every single thing over here. So I've lost all my progress irrevocably. Let me also delete these and reset to default position. Let's try putting in a new cube at, I don't know, some position, and we're going to pretend that I just lost a lot of progress. Okay, that seems like totally hopeless. What am I going to do now? Well, have no fear, because you can actually load that file you just made, test.json. If I were to load it, all of my objects will appear back at their original positions that they were at. Okay, so you can see here that that cube was still there. Now, that cube was hidden earlier, but it is shown now. You can consider that a bug if you want. This is still in the developmental test stage, so there are some things which may not work as expected. That cube was hidden before I saved it, but right now it is being shown. Okay, so let's hide it. But everything else is in the same position as it was before, and that line and plane is still being shown. Everything is here. I can continue to reflect and rotate and do whatever I want, although I will say that that undo stack is not going to work anymore. Okay, if I were to press undo on this hexagonal prism, it's just going to undo the last transformation, which was the crown, so that deletes. So that's one more thing I wanted to mention, I should have mentioned. If you click the undo button, it actually undoes the last transformation on the global level, not the one that's actually selected. So let's cover that just to show you what I mean. So let's reset this. Let's show this object. if I were to take the tetrahedron and put a new one here, let's translate this to 1, 2, 3, and let's translate this to 1, 2, 5, or 6. You can see I've translated both. Now, if I select the cube, but that tetrahedron was the last thing that moved, so if I press undo, it will go back to the original position first. And then undo the cube, delete the tetrahedron, and then delete the cube finally. So that's pretty much that. So again, we can just load back that file, and all of our shapes will be here again, albeit all of them will be shown by default. So do bear that in mind. But anyways, that is pretty much everything I have to show about Visual -1 3D Visualizer. This has been a long video, I know, but I hope that this has given you a little bit of insight into what we are doing and what are just some of the applications of linear algebra. We used total least squares to find a best fit polygon. We used matrix multiplication to transform objects, okay? So now, unfortunately, when you do save, it just stores your position, but not the transformations applied to them. So this is just the identity matrix. But again, if I were to translate, then that's represented by a matrix transformation. So you can actually see all of the transformations that are being applied in order. And one more thing, if you were to click this, add a new 3D shape, all of the shapes that we added so far, they're saved. You can still see them. And I can still add a hexagon or a crown, okay? Or I could go back. I could also straight up just delete any of these shapes if I don't want them anymore. So if I don't want the crown pyramid anymore, that's my guess. If I don't want the pentagonal pyramid anymore, then so be it. The ones that are still on the screen will still be there, but that, you cannot create a new one anymore, okay? We can add a hexagonal prism, and it will still have one over here, right? Now, finally, you can also delete the cube and the tetrahedron, but these are special shapes. These are stored internally as special shapes, so if you delete them, they'll just regenerate right there the next time you reopen Visual -1. So if you do accidentally delete this, don't worry. They'll reappear when you reload the app. So it's been a long video, but that basically explains the current feature suite of Visual -1 3D Visualizer. There are a couple of minor bugs that we could iron out in the future, but do let us know of your feedback of what are the features that are available for display right here, right now. And in the future, when we are ready to show you more things, such as 2D image processing, then we'll also be making demonstration videos for those. So yeah. Thank you so much for watching. Thank you so much for your time, and I hope you find this project interesting and enjoyable. And I hope it'll give you some insights into what we do with linear algebra. Yeah, that's it. Thanks for watching.